Hello, this is Eric Lingerfeld, the lead developer and software architect for the Bellerophon software system. One of the unique things about our system is that in addition to visualization and analysis and data management, we also offer tools that developers need, HPC application developers need, uh, in one central location. What we're looking at here is the SVN statistics on demand. So this allows us to generate statistics for any code line, for revision min and max, or a date min and max. We can, and what it does, we will run what's called stat SVN, which is a library that generates statistics, but we will use that library on the back end and then download a bunch of HTML web page content with the statistics in it and put it into this directory on my laptop. We also have the SVN log viewer, so I can click that and it goes to the back end. The web server gets this information, brings it forward to us so we can go ahead and make a good solid judgment about what range of statistics we want to do. So I'm going to just go down and pick a random one here. Now when I click generate SVN statistics, it's going to go back to the web server. We're going to run the stat SVN library to generate the statistics, and then we're going to download it to the computer. Now when I do this, it's going to take a few minutes for it to be generated, possibly maybe about 30 seconds. So please be patient and we'll look at the stats together. Sorry about the long wait. I think it takes maybe about 90 seconds. But once it kicks in, we'll start seeing the files start to download into the directory that we indicated in the previous step. Of course, you have the luxury to click the fast forward button, so I would suggest that you do so. hmm. There we go. So now it's downloading all of these files from the web server that contain a bunch of statistics in a nice web page container. So it's downloading it to my system. Usually, if we're on a fast connection, these things just zoom by, but we'll wait until it's done. And we use all of these tools very often to gain insight into not only code development but who's concentrating on what module and so forth. Chimera is a multi-physics, multi-dimensional code that runs on up to 200,000 cores, and it's been in development for a couple of decades now. We're almost done. All right. So now let's go ahead and view these statistics. We just click that button, and it opens up the web page with some of the statistical content. We can see a lot of cool things here. We can go look at developers. We can look at contributed lines of code. There's a developer of the month. We have a commit activity log. And we have all kind of really useful information. If we go back, and of course now we're looking at this on my desktop. We can look at lines of code and churn level. We can look at a cloud commit and see what words are coming up most frequency. We can look at commit logs for a particular month, and we can look at logs per person and see the activity by day of the week for Dr. Lentz. We can look at all kind of really useful information. It's at our fingertips, and you can just click a button and it's there. We can look at different directory sizes and explore different directories within the trunk. We can look at different lines of code. Well, that's a useful one. You can see here how the lines of code from 2013 to 2015 jumped. So they've been doing a lot of work. We can look at file statistics about particular files with the most revisions, largest files. But the cool thing is the repo heat map. Now, I hope this works. Sometimes the lab computer blocks it. So what we're doing, we're loading up a J tree map. And unfortunately, this software only allows us to look at the past month. But anyway, or the past 30 days. So what here, we are actually, each one of these represents a different directory in Chimera's tree. And we can actually go down and look at files, and it'll give us the line of change for each one of these guys. So you can kind of take a look at, who's working on the most stuff. Of course, nothing's taking place there. I don't know what they've been working on recently, but there haven't been any lines of change there. Maybe the make files are, no. There's that. Anywho, in any event, here we go. So we can go down here and see that the equation of state wrapper module .f has been changed 13% with 762 lines changed. So each one of these squares is a file, and each one of the big rectangles is a folder. So you could very easily see, though, how this technology would be incredibly useful to any HPC application development team.